Developed by researchers at NVIDIA, this is an LLM-driven assistant designed to transform those incredibly complex, flat failure traces into actionable, ready-to-use RTL fixes. In fact, it consumes nearly 50% of a verification engineer's time, making it their single largest daily activity. The heavy manual burden of staring at disconnected traces across multiple cycles and trying to decipher what went wrong can literally stall development for hours, or sometimes even days. First, there's manual debugging, where engineers are limited by human tracing and have to build a mental model from raw waveforms. Then, we have naive LLM analysis, which just looks at flat text logs but suffers from a high false positive rate and tends to hallucinate invalid patches. And finally, we have FVDebug, the true innovation here. It uses explicit causal graphs instead of flat text, utilizes multi-cycle agentic navigation for deep reasoning, and drastically lowers false positive rates using a clever for-and-against prompting technique. The end result? Validated RTL diffs and a ranked debugging report. Look at the left side, flat text completely obscures causality, making it incredibly hard to see why an error happened. On the right, we have a causal graph, which explicitly maps out dependencies. Normally, humans have to trace waveforms backward manually to build this structural mental model. FVDebug builds this explicit structural model automatically so the LLM can easily understand it. It operates in 4 main stages. First, causal graph synthesis, which turns the raw counterexample into a causal graph. Second is the graph scanner, which uses token-aware LLM batching to find issues. Third is the Insight Rover, an agentic explorer that navigates the graph. And fourth is the fix generator, which creates the actual RTL patch. Let's break these down. As you can see on the left, a raw trace looks like a messy, sprawling tree. Through a process called graph consolidation or node deduplication, FVDebug merges duplicate signal cycle pairs from reconverging paths. It recursively queries causal parents up to 20 cycles deep, resulting in a clean, computationally tractable explicit causality map on the right. It uses token-aware batching to fit within a 50K token LLM context window. It prefetches context like RTL snippets and design specs so it doesn't waste time retrieving the same data twice. It then scans the graph level by level, maintaining strict causal context for the LLM while maximizing how fast it can process the data. Standard LLM prompts naturally assume that if logic matches behavior, everything is correct, leading to confirmation bias. FVDebug forces the LLM to act like a prosecutor and a defense attorney. It must explicitly stack arguments for the signal being suspicious and arguments against it. This dramatically reduces confirmation bias and stops the AI from flagging false positives. Instead of exhaustively searching every single path, which would take forever, the LLM acts as an autonomous agent. It dynamically explores active narrative paths and prunes weak ones, those with less than 20% confidence. This selective, intelligent exploration reduces the search space by over 90% compared to a standard breadth-first search, ultimately landing on a highly confident, ranked root cause hypothesis. FVDebug doesn't just guess once, it uses an ensemble fix generation approach. It applies 5 different prompting strategies ranging from full system-level context down to surgical, minimal context. These fixes are then fed into a validation and consensus engine. Fixes that are generated by multiple different strategies receive a higher confidence score, resulting in a single, highly validated RTL diff. It collapses millions of data points into 2 simple things: a validated fix showing the exact buggy code and the corrected code, and a ranked report. The report gives human engineers a clear hypothesis, supporting and contradicting evidence, and a human-readable cycle-by-cycle causal timeline. On academic benchmarks, FVDebug achieved a massive 95.6% best hypothesis quality. When it comes to actually fixing the code, it had a 71.1% success rate on the very first try, and an 86.8% success rate within its top 5 suggestions. The chart here also shows an ablation study. If you remove the Insight Rover or the for against prompting, performance drastically degrades, proving that narrative construction and balanced reasoning are essential. FVDebug has been proven to scale up from 38 open benchmarks to complex CVA6 RISC-V processors, all the way up to proprietary production designs containing 500,000 lines of code and 15-level deep causal chains. On these massive designs, FVDebug automatically extracts the deep causal graphs and pinpoints the root cause in a matter of minutes, perfectly matching human expert diagnosis. Thank you for watching this overview of FVDebug.